For over a century, the internal combustion engine was the soul of the automobile. Complex, powerful, and loud, it was a marvel of engineering, a symbol of progress, and the driving force behind the global car culture. The roar of pistons and the smell of gasoline became synonymous with freedom and adventure, shaping the way generations experienced the open road. Now, as we shift to electric vehicles, the electric motor takes center stage, quietly transforming how we move. The hum of an EV is almost imperceptible, a stark contrast to the engines of the past. This new heart of the car is not just quieter, it's more efficient, more responsive, and fundamentally changes our relationship with driving. While battery range and charging get the headlines, the real revolution is happening inside the motor itself. The electric motor is where energy is turned into motion, and its evolution is just as critical as advances in battery technology. Traditional motors rely on copper coils and rare earth magnets, but innovators are reimagining these core components. Engineers are questioning every assumption, searching for ways to make motors not only more powerful, but also more sustainable and easier to manufacture at scale. The goal: motors that are lighter, more powerful, and less dependent on materials with unstable supply chains and heavy environmental costs. Reducing weight means longer range and better performance, while new materials could make EVs more affordable and accessible worldwide. This has sparked a race to develop new designs, some using contactless induction, others exploring carbon-based construction. The stakes are high. Whoever cracks the code could reshape the entire industry, setting new standards for efficiency and sustainability. Today's motors, though efficient, depend on rare earths like neodymium and dysprosium, which are costly to extract and concentrated in just a few countries. This creates geopolitical risks and supply bottlenecks, making the search for alternatives even more urgent. Their mining is environmentally damaging, and copper's weight and price add further challenges. The environmental footprint of these materials can't be ignored if we want EVs to truly deliver on their promise of sustainability. As EV adoption accelerates, these limitations are becoming critical. The world's appetite for electric vehicles is growing fast, and so is the pressure to find better solutions. The industry's future depends on coil-free and rare earth-free motors, not just for performance but for true sustainability. These breakthroughs could make electric vehicles cleaner from the inside out, reducing their impact on both people and the planet. This is about building a cleaner, more resilient automotive future, not just swapping one set of problems for another. The choices we make now will echo for decades, shaping the cars we drive and the world we live in. The innovations emerging now are the first steps toward that vision. As we rethink the very heart of the electric vehicle, we're not just changing how cars are powered, we're redefining what's possible for the road ahead. The shift to electric vehicles isn't as simple as swapping gas for green. It's a transformation that touches every part of the automotive world, from the way cars are designed to the resources that power them. Most high-performance EV motors rely on rare earth magnets, creating a new dependency that's both strategic and environmental. These powerful magnets are essential for compact, efficient motors, but their supply is far from secure. The supply chain for these elements is dominated by a single country, making automakers vulnerable to geopolitical shocks and price swings. This concentration of supply means that a single disruption can ripple across the entire industry, threatening production and innovation. This risk is driving a global push for rare earth-free motors. Researchers and engineers are racing to develop alternatives that can match or even surpass the performance of traditional designs. It's not just about finding substitutes, it's about rethinking the system entirely. New materials, innovative designs, and smarter manufacturing processes are all on the table. Rare earth mining is toxic, generating hazardous waste and undermining the green promise of EVs. The environmental cost is high, with pollution affecting local communities and ecosystems. Consumers and regulators are demanding cleaner supply chains. They want electric vehicles that are truly sustainable, from the mine to the road, and are pushing automakers to be more transparent and responsible. Motors that eliminate rare earths offer a way to stabilize costs, reduce risk, and align with true sustainability. These innovations could make electric vehicles more accessible and environmentally friendly for everyone. The industry's pivot is about more than materials. It's about building a resilient, future-proof foundation for electric mobility. This shift could redefine how cars are made and what it means to drive green. By moving away from permanent magnets, automakers can escape the geopolitical chess game and environmental compromises. It's a strategic move that could reshape the global auto industry for decades to come. The race is on to make this vision a reality, and the outcome will shape the future of transportation for generations. Leading Europe's charge for magnet-free motors are Mahle and Valeo, with their groundbreaking IB motor. The IB uses electromagnetic induction to power the rotor wirelessly. No rare earths, no physical contacts, and far less wear. At its core is Mahle's magnet-free contactless transmitter, enabling seamless, maintenance-free operation. The result, a motor that's robust, efficient, and projected to deliver up to 350 kilowatts at over 95% efficiency. Environmental impact. The IB could cut the motor's carbon footprint by up to 40% compared to conventional designs. With commercial tests on the horizon, Mahle and Valeo are setting a new standard for sustainable, high-performance EV motors. The IB is proof that ditching rare earths doesn't mean sacrificing power or reliability. In the US, Texas A&M's team, led by Dr. Hamid Toliat, is taking a different path, replacing rare earth magnets with copper coils in the rotor. This bold move challenges the status quo of electric motor design, which has long relied on rare earth elements for their powerful magnetic properties. Copper is abundant, affordable, and globally sourced, making it a stable alternative. Unlike rare earths, which are often subject to volatile markets and geopolitical tensions, copper is widely available and less prone to sudden price spikes or supply disruptions. The team's prototype matches the power-to-weight ratio of top magnet-based motors, but with lower costs and fewer supply chain risks. This means manufacturers can maintain high performance while reducing their dependence on hard-to-source materials. Backed by major funding and US patents, their motor has already passed rigorous real-world tests. These achievements demonstrate not only technical feasibility but also commercial readiness, paving the way for broader adoption. This approach doesn't reinvent the wheel, it smartly re-engineers proven designs with more sustainable materials. By focusing on innovation within existing frameworks, the team ensures reliability and scalability for mass production. For automakers, it's a practical, easily integrated solution to move away from rare earths without overhauling factories. This compatibility means companies can adopt the technology quickly, saving both time and resources. Texas A&M's innovation highlights the crucial role of academic research in solving industry-wide challenges. By bridging the gap between theory and application, universities can drive real change in the marketplace. It's a pragmatic step toward a more resilient and cost-effective EV future, one where sustainable materials and smart engineering work hand in hand to power the next generation of electric vehicles. In South Korea, KST researchers have built the world's first electric motor using carbon nanotubes instead of metal coils. This all-carbon design is a game-changer, over 80% lighter than copper yet nearly as conductive. Every kilogram saved means more range and better performance for EVs. The breakthrough came with a new process, LAST, which boosted the conductivity of carbon nanotubes by 133%. Their prototype powered a toy car for over an hour, proving the concept's potential. While early stage, this technology points to a future of ultralight, metal-free motors. It's not just rare earths that could be left behind, metals themselves may soon be optional. KIST's work signals a new era of electric propulsion. These new motor technologies promise sweeping environmental and economic benefits. By eliminating rare earths, automakers can cut ties with destructive mining and toxic waste, making EVs truly green from start to finish. Motors built from abundant materials like copper or carbon nanotubes mean more stable prices in supply chains. This stability could lower manufacturing costs and make EVs more affordable, speeding up global adoption. Diversifying materials also reduces the industry's vulnerability to supply shocks and geopolitical leverage. For countries like the US and EU, developing rare earth-free motors is a matter of economic security and job creation. The shift encourages local innovation and advanced manufacturing, building a stronger, more competitive industry. The result, a cleaner, more resilient, and economically robust future for electric mobility. The impact of these innovations goes far beyond cars. Lightweight, efficient, and sustainable motors will transform industries from wind power to aviation and robotics. Wind turbines could shed tons of rare earths, cutting costs and environmental impact. In aerospace, ultralight motors like KIST's could enable longer flights and heavier payloads. Drones, trains, ships, and even household appliances stand to benefit from cheaper, more reliable, and greener motors. The work at KIST, Texas A&M, and Mahle isn't just about better EVs, it's about building the foundation for a sustainable, electrified world. The electric motor revolution is just beginning, and its reach will be global.